The sun is white, space is black, and yet when you look up from Earth, the sky is blue. Why is that? To answer that, let's follow a single beam of sunlight on its way to Earth. Sunlight is made of electromagnetic waves with different wavelengths, like red, green, and blue. Together, they appear to us as white light. After about 8 minutes crossing space, this light reaches Earth's atmosphere, a thin shell of mostly nitrogen and oxygen. Each molecule is tiny compared to the wavelength of visible light. As light passes through the air, its electric field pulls on the charged particles in each molecule. These charges start to oscillate at the same frequency as the light. The molecule becomes polarized. These oscillating charges behave like tiny antennas. They re-radiate light and send out new waves in many directions. This is called Rayleigh scattering. The important part is that a lot of the scattered light is sent sideways. Seen from the ground, all this sideways scattered light from countless molecules is what makes the sky bright. The strength of Rayleigh scattering depends very strongly on wavelength. It scales roughly like 1 over the wavelength to the 4th power, which is why shorter wavelengths scatter much more strongly than longer wavelengths. So, blue light is scattered several times more strongly than red light. As sunlight moves through the atmosphere, blue light is constantly thrown sideways by air molecules, while red light continues almost straight. During the day, when you look up away from the sun, the blue you see is this sideways scattered blue light from countless molecules in the sky. When you look toward the sun, you see the remaining direct sunlight. On its way to you, much of its blue has been scattered out of the beam, so the sun's disk appears slightly warm and yellowish. At sunrise and sunset, the sunlight travels through a much longer path of air near the horizon. Along this journey, almost all of the shorter wavelengths are scattered away before the light reaches your eyes. What remains in the direct beam is dominated by red light. That's why sunsets and sunrises glow in warm colors. There is one more question. In the spectrum of sunlight, there are wavelengths even shorter than blue, violet. So why isn't the sky violet? 2 main reasons. First, the sun emits less violet light than blue. Second, our eyes are much less sensitive at those very short wavelengths. So even though violet light is scattered strongly, the scattered light that actually dominates our perception is blue. So when you see a clear blue sky, you're seeing white sunlight scattered toward you by a thin layer of air around Earth. And that's all it takes for the sky to be blue.